Hello everyone. Today we're going to talk about some of um, Gaussians. Basically, here we are going to some two distributions, and what we see is that the sum of two normal distributions is also a normal distribution. And I will give you an example. Um, we can take the example of, for example, let's say a total response time of a computer system. Let's write it like that: total response time of a computer system. Computer system. And we can also see what it depends on. It depends on the processing time of a computer. Processing time of a computer. And it also depends on the network latency. Network latency. Now let's denote the processing time with T and the network latency with L. And the total response time R will be T plus L. And of course, it's a random variable. The processing time is a random variable, and network latency is a random variable that follows a distribution. And in this case, we are specifically choosing normal distribution. And if it's a distribution, then it has a mean and the standard deviation. And let's choose ten for the mean and 2 for the standard deviation. And for the network latency, what we are going to choose, L, let's make its mean 5, and 1 its standard deviation. And one more thing that I have to mention is that these distributions are independent of each other. So the random variable that takes any value in this span in processing time, it does not depend on the network latency, and the other way around is also true. And I will just roughly draw these graphs, first starting with the processing time distribution. Processing time distribution, and it will be something like that. Oh, it's an actually normal distribution. It doesn't look like a normal distribution. Maybe something like that. Yeah, it's more like a normal distribution. And okay, this is T. And for a network latency, we are going to draw this distribution. Let's choose the color blue. Yeah, because roughly speaking, you can see the standard deviation of this distribution is less than the one on the left. So that's why the distribution looks like this. Looks skinnier. Okay, after drawing these distributions, and let's say each time we make 1000 observations, and we draw histograms, and it will be something like this. because it's a continuous distribution, and you know continuous distribution is nothing but um, a, a bunch of histograms, but the thing is the number of histograms, I mean these bars are infinite. Okay, we have this histogram here, and we have it here. Okay. And in each case, we took the sample. We sampled each variable 10,000 times, and we came up with this distribution. Both are normal distribution, even though the one on the right doesn't exactly look like a normal distribution, but it was just for the visual purpose. And now let's draw the graph for R, the total response time. And we can see that it also follows a normal distribution. And so these are the histograms. And this is R equals to the processing time plus L. And you can see R is still a Gaussian distribution. And we can also write that the expected value of R, is the expected value of t plus L, which is expected value of t plus expected value of L, right? This is one of the basic properties of expected value. And what it also means, so this is basically the mean of the distribution, the expected value, and this is the mean of the distribution of processing time, and this is the mean of the distribution of a latency. So basically mu r is mu t plus mu L, as you can see. So when we are trying to sum two distributions, we can find the expected value or the mean of the new distribution like that by just simply summing the expected value of two distributions. And let's say what was the expected value of 10 plus 5. So it will be 10 plus 5, which is 15. Okay, what about the variance of this distribution? Let's see. Variance R. And again, the variance of R is variance of t plus L, and it's the same as variance of t plus variance of L, which is basically was the 2 plus 1, I guess so, 2 plus 1, oh sorry, 4 plus 1, Yeah, 4 plus 1. Because I think, yeah, this is not actually, this whole thing is not the standard deviation, it's actually the variance. This one is standard deviation, this thing here. And when we raise it to the power of 2, we get the variance. Because as you can remember, when we try to find a standard deviation, we actually take the square root of the variance of the distribution. So basically that's how we find, when we sum to Gaussian distributions, we can basically find its a variance and mean by just summing the variances of two other distributions and the expected values as well, if you want to find the expected value.